Alright, hello, this is Daniel Reyes. This is my final project. It is an Arduino keyboard. It is a functioning musical instrument. Now originally I wanted this to be more of a game or an ear training device. It was meant to play back pre-recorded melodies or tones, certain scale degrees, and the player would have to go ahead and recreate those tones or recreate those melodies back, and if the player got it correct, it would have added to their score, it would have taken them to the next level, something like that. And if they had gotten it incorrect, it would have taken away from their score, it would have ended the game, recorded a high score, something like that. Unfortunately, I could not fit an LCD screen, which is what my original plan was, onto the breadboard with the rest of the buttons. And without the LCD screen, I couldn't think of a way that was meaningful to implement the game in a way that was easily represented to the player. And as you heard, it does play all scale degrees of a scale, from the tonic, or the root note, all the way up to the tonic again, or the octave. How I achieved this was through a resistor ladder. Some of you may be familiar with the idea. It just reduces the voltage going to each individual button up until the lowest amount of voltage comes out of the button to an analog input, which is recorded in this serial monitor. And this is actually how I determined what values, or what inputs to assign to each tone. So if I push a key, you can see it gives an output in the serial monitor, pretty consistent output. And I push the next key, it's a different number, and the number is lower and lower each time. So I have pretty consistent outputs, I don't know if you can see that, to compare, which makes it easy to assign each key to each tone. Now, what makes this keyboard unique from other keyboards, like the one that you may see in the Arduino projects book, or the one that you might see on the Arduino project hub, is none of those can, well, first, most of them, like the one in the book, don't play an entire octave. They only play, like 2, maybe 3 notes. I think the one in the book plays 3 or 4. Some just kind of stop at the 7th scale degree and don't resolve to the tonic there. So I wanted it to go from scale degree 1 to scale degree 8. I wanted an entire octave. The other thing is that this is capable of playing different keys. Now I hope you can tell that that is a different scale. And again, which is different from our default scale, C major. So I wanted it to be able to store different keys and play different scales. For example, this is a whole tone scale. And since the basic algorithm that is actually responsible for playing these notes, right, it takes this key value, which is an integer value of the analog output from the button to pin A0, which are the numbers over here that we saw in the serial monitor, and it takes those and it compares them, right? So certain values on the serial monitor will correspond to specific notes coming out of the speaker. Now that algorithm is basically already it's the same thing as in the book. What I did was I made it possible to switch between certain scales. Now I only stored as many scales as there were buttons. I'm sure there's a solution to store more scales. I didn't go for that. I just, you hold down the key change button, hit a different button. Whatever button that corresponds with in a scale will play that scale. The keyboard, rather, will play that scale. So while this key change state, which is controlled by the key change button, which is in digital pin 7, when that is pushed down, when that state is turned to high, it will again compare those same analog outputs. And whatever analog output is identified, it will correspond with a specific scale. So if we push the 6th button, we hit the key change button, we hold it down, hit the 6th button, we now have a B flat augmented 5th scale. The scales I wanted to store in the Arduino itself, as you can see, they're here in order. They correspond with each button. So first, second, third, fourth, as you see them appear here, will be those corresponding buttons. They're just arrays with integers, and those integer values actually correspond to the frequency in hertz of each of those tones. And when the default array that is used to play the notes down here, as you can see, tone in 8, play this corresponds to an integer value, which will be turned into hertz that will come out of the speaker. When a scale is selected in this first algorithm here, the corresponding scale degrees in each of these arrays is actually replaced with the scale degree from whichever scale is being selected. That is basically how this keyboard works. So one last time, we can change the key. Play a G harmonic minor scale, or we could go back to the default C major scale.